So in the next bit of time, we're going to take a look at big data from a security perspective. And I wanted to do two things today. I wanted to talk about a couple trends at the macro level of the market, and then go into the technology and look at some of the technical approaches to securing sensitive data in the context of big data. But before that, I thought I would just color my remarks with a couple of sort of high-level thoughts. Big data is one of those technologies that, unlike a lot of other technologies in IT today, it's really starting from large enterprise down. You know, if you look at the consumerization of IT, and certainly in healthcare, the tremendous uptake in mobile device technology, collaboration technology, some uptake of cloud, but a lot of those technologies came from consumers and up, and they started to shape the security starting from that premise. One of the nice things about big data is it starts from large enterprise down. And so some of the security tooling that we focused on in large enterprise can be brought into Hadoop rather quickly. I think the other sort of interesting thing happening in the market today is we're kind of out of the beginning. We're going to talk about a little bit of where customers are at and what it means to be at the end of the beginning. But from our standpoint, the end of the beginning means people are finding real applications that can drive real revenue with Hadoop. But the end of the beginning is also some of the reality of being in a large enterprise environment. So high availability, automation, scalability, resiliency. And you're really seeing that in the Hadoop technologies. Hadoop 2.0, really a lot of emphasis on reliability, a lot of emphasis on real-time processing. And we'll take a look at what that means from a security standpoint, technically. I think, you know, at the broadest level, customers want to get going with Hadoop, but they are constrained in security today. The constraint is pretty obvious. I'm going to be aggregating more sensitive data in one place than I ever have before. And so from a risk standpoint, customers are uncomfortable with the increased risk position that Hadoop represents. I think historically, when you think about data aggregation and risk, if you think about this from a data warehousing standpoint, it was in the very back of the office that there sat Teradata or Exadata or Netezza or some other data mart, and therefore security measures could take place in front of it. One of the challenges in Hadoop is the audiences are much more dynamic, and the data sharing is much more dynamic, so that construct that it's at the very back of the office starts to go away. And we'll take a look at some security techniques around data protection so that you can tackle that. A couple fun ideas to kick things off. Where are we at? You know, we've been doing big data in different applications for arguably over 100 years. A good example is the U.S. Census. U.S. Census in 1880 was a manual process. People went out and counted people, tabulated it on paper. What's that? Oh, is that right? Yeah. All right, I guess we can go downstairs and see the Hollerith machine. So, for those history buffs, we're in the History Museum of Computers today, and this machine sits downstairs. The point is, technical innovation and methodology can speed things up. By 1890, 63 million people in the U.S., so the U.S. population grew by a little over 20%. But notice that with this new technology, they took the tabulation task from 7 years to 6 weeks, 76 times faster. We've been dealing with big data for a while. Where are we at now? You know, I have this idea that we're at the end of the beginning. Winston Churchill has this quote. This was actually during World War II. He sort of got a bit of relief from all these German bombing raids every night. And by August of 1941, the British Air Force had kind of come over the Germans in terms of an understanding of how to attack them. Obviously, a role of big data played a role in that warfare. The British had the advantage of radar, which gave them incredible data, incredible real-time insight to the planes, and they could actually wait to launch their planes until the German planes were well over British air territory, which gave them a compelling advantage in agility and insight. And that's really, our customers are trying to do the same things with big data today. I think the fundamental driver for why Hadoop versus other processing technologies is today measured by speed. Speed of getting answers faster and speed of saving money faster. Of course, with that said, one of the key challenges in trying to get an agile information model out of big data is this overwhelming growth of data versus no growth in your stats today. And this is sort of one of the fundamental challenges that we see in front of us at the end of the beginning is, okay, I know I'm going to aggregate new data together. I know my data is growing year over year, doubling, and so that those numbers get crazy really fast. You get 75,000% data growth in 8 years, but you don't get the commensurate growth in your staff. And so what we hear back from that is, I can't afford to add more people to security. I've already got headcount and resource problems managing this data already. So we take that to task. We think the assignment of security in big data is to be as transparent, as automated as possible, so that you can get back to managing this walloping growth in front of you. So that's sort of challenge number one, is you've got this people problem. Challenge number two is the sort of promise of Hadoop and the promise of big data architecture today is the melding of structured data and unstructured data together. And so this chart represents, I don't know how clear it is to the back of the room, but essentially the expected growth from here, this doubling of growth every year for the next 8 years, a lot of that growth curve comes on the unstructured side of the curve. And we've been talking a little bit about that this week in semantics and analytics and other places. How do you manage and handle unstructured data? So I'm going to talk about unstructured data protection in my presentation. Clearly, it's a challenge to go find, classify, and log that data when it's not announcing itself in rows and columns that you can go identify. And real quick, a couple sort of real-world models of unstructured data happening in Hadoop today. Some customers, for customer service optimization, are trying to do analysis of their call centers, so they're taking basically voice recordings, turning them into text, and driving them into Hadoop to figure out quality control for call centers. 3M, this is actually 3M's Healthcare Information Services Group, does a lot of information aggregation as a service provider to healthcare and sees just a wide array of unstructured data elements flowing through systems for Hadoop, and really challenged by HIPAA compliance. How do they ensure PII protection in PDFs and other data sources where that data doesn't necessarily announce itself. Onto the web, we see a lot of applications looking at customer surveys, looking at free forms of text, comment fields being analyzed with Hadoop, but the concern here is, what if someone does the wrong thing with a comment field? For this online payments company, you've probably seen their logo when you try to buy things online. Customers sometimes do the wrong thing. They say, this purchase didn't go through, and here's my credit card information, can you go fix it? And so it's really trying to stop people from putting data into places that it shouldn't belong to begin with. This is a customer with 6,000 nodes of Hadoop today. The last thing they want is a sort of PCI audit, a PCI scope touching that infrastructure when the intent of that infrastructure is to never have credit card data in it in the first place. And then every once in a while we see, unstructured, semi-structured data coming in completely, outlier applications that we never thought were coming, or even regulatory forces coming from places we didn't know about. Halliburton does a lot of oil drilling around the world. It turns out that they've got compliance challenges with that data. You're not allowed to merge data from 7 embargoed countries with oil drills from other countries. So they're not allowed to introduce semi-structured wellhead data from Rwanda because it's one of the embargoed countries regulated by the Department of State. A lot of myriad use cases for unstructured data really starting to percolate now. This is really my last idea on market trends, and then we're going to jump into a look at the technology coming up. So we've talked about growth of data leads to a headcount problem. Variety of data leads to how do you look at protecting unstructured data that might have sensitive elements in it. And the last idea that I want to talk about is really this notion of evolution. Not to imply any of you were chimps or apes or crawling or anything, but people start in Hadoop with really this idea of a lab project. And it's not really an appropriate time to look at security. The lab project is really a time to figure out what is this set of technologies, where can I apply it, what might be some of the applications for it. If sensitive data is going into a lab, people generally don't care about it because it's deemed to be a private test that's never going to go anywhere. It's data that was already sensitive, so its application of sensitivity in Hadoop doesn't really change anything. Customers then move to what we call the proof stage. I think there are some large healthcare providers today in the proof stage that we're working with. Interesting opportunities for Cardinal and Sutter, Blue Cross and Blue Shield, United Healthcare, moving out of proof and into ROI validity. So proof is about, I've got a specific idea that now that you've shown me a technical approach, I can actually build an application that can do something with it. And the introduction of security really comes here in what we consider to be ready to go prime time, which we call sort of ROI validity. This thing will save me money, this thing will give me new insights. And this is also the moment that our customers generally find the security aha moment or uh-oh moment. Aha being, there's a lot of elements in here, and we have to introduce this architecture to InfoSec and audit and compliance, and they're going to pay attention to it. And the uh-oh moment is sort of the equivalent, which is there's a lot of sensitive data in here, audit and compliance are going to get notified of it, and they're going to pay attention to it. And one of those leads to a good result, that they're allowed to go forward, and one of those leads to a negative result, which is security starts to become an encumbrance, either stopping the project, slowing down the project, or adding other methods that we'll talk about in a moment. Where we see the customers that are really advanced headed is what we call on-demand Hadoop. And the ideas behind on-demand Hadoop are, this is full-scale production, but perhaps more important, new use cases are ad hoc into the system, which means they don't even know what they don't know yet, but they want to bring the data in and allow new applications, new users, new data sets in a very runtime, ephemeral way. They don't know how it's going to be built, but they want to make the technology available. And United Healthcare calls this data architecture as a service. We know we have enough richness in consolidating data in Hadoop that different applications will simply come and build from a data architecture as a service environment. This is clearly a time where security has to be sanctified, security has to be understood end to end. But how do they get stuck? I talked about this idea of the uh-oh or frozen or challenged with security. We see a lot of customers, some in healthcare, but also in finance and web and manufacturing, stuck at this notion of how do I protect sensitive data in Hadoop? I'm going to just put it in a penalty box. And by penalty box, we mean I'm going to network isolate it, I'm going to use firewalls, I'm going to use restricted ACLs, I'm going to use two-factor authentication, I'm going to make sure I only have a narrow set of users with narrow sets of data, and I'm going to monitor how they touch and access the data. And I think they're challenged because the market for tooling security inside Hadoop wasn't there. So Hadoop wasn't invented with an implicit path for data protection. So we'll talk about it in a moment. But this idea of penalty boxing Hadoop is where a lot of customers are at. And what they really want is some automated way to know that sensitive data stays protected and that they don't have to be firewalled off, zoned off, ACL'd off, perimeterized off, and that new users can be added quickly, new requests of the data can be made quickly. And so that sort of wraps my, I promised we were done by noon, so for those people thinking about lunch, we're almost halfway through. That was sort of my market summary. I wanted to do three things. Talk about the 3 V's and the sort of reality of where we're at from the security requirements for volume. The security requirements for volume and really real-time processing of data is driving a set of security that has to be scalable, automated, and resilient. And that's really a theme that you'll see this year going forward, that the new architectures are going to be measured by resilience, automation, and real-time performance. And so, we're mindful of that in our security solutions. We want to be resilient, scalable, and automated in an equivalent way. Expect more data variation. Data variation is going to drive unstructured data, which isn't going to announce where the PII and HIPAA elements exist. And so we think there's an increasing role for discovery, risk scoring, what is out there where in this data, and aggregation knowledge. Netflix ran into a bit of trouble with their data project. Netflix wanted to encourage data scientists out in the wild to make use of 100 million user recommendations that they had captured throughout the years of running Netflix. So they ran a contest, they published 100 million records, and they did the right thing. They de-identified the usernames from publishing that, because they didn't want to expose individual usernames. Per their privacy requirements, they weren't allowed to. But someone else out in the research community noticed something. People that make recommendations on Netflix also sometimes make recommendations in IMDb. And unlike Netflix, people that make recommendations in IMDb sometimes put their name on this. And so it turns out that in 100 million movie recommendations, this inference or co-joining of data led to 8,000 actual users that they could tie together from blending this data together. And that's sort of a pretty advanced, sophisticated case of an inference attack or an aggregation attack. But I think it's coming, and I think it might be particularly coming quicker in a healthcare context, because you have different bodies owning similar clouds of data. The ability to infer from date of birth or zip code or username or even healthcare provider membership starts to create risks that you might not be aware of from your version of the cloud versus other aggregated sources of the cloud. And so when I say expect more data variation, it's not just I've got PDF doctor's notes that I need to be mindful of addresses in. It's I've got PDF doctor's notes that I need to mask addresses that someone might also be able to co-join based on date of birth and zip code against someone else's name. And so tricky problems, but problems that aren't insurmountable either. Last but not least, this notion of trending, where customers move through an evolution. What does it mean to be ad hoc? What does it mean to be real time? We think the burden on security is to be transparent and sort of secure by default, which is if you can build the data models in ways that the intrinsic protection is already inside, you can quickly add new requests, add new users, share out the data, and not have to block those things. So we're going to talk about data element protection as a way to start from secure by default. I mentioned this idea already that like other infrastructures, security was not intrinsically part of Hadoop, and it creates some challenges from a security standpoint. This is a highly distributed environment, a high data volume, high performance, high velocity environment. This is an environment where you are, by design, allowed to run arbitrary ad hoc code. And so, some of the existing infrastructural approaches are getting applied, but they're under some degree of strain or constraint. So existing authorizations around Kerberos, ACLs can help mitigate the broader risks, but they do not on their own do enough to address compliance and insider threats that may lie underneath. And so ultimately, a more rich, data-centric blocking of sensitive data, hiding sensitive data, redacting the data you can redact, one-way masking it to a unique value that never comes back, are additional techniques that you can do at the data level to protect yourself on top of the things you can do at the infrastructure level. And that's really the sort of blended security approach we see customers doing today. This is a slide I borrowed from Cloudera, but essentially the thought here is you've really got 4 different ways to think about security in this. You've got access security, who can get to what. You've got perimeter security, make sure the wrong people can't get in at all. You've got visibility and reporting, where is sensitive data being accessed. And lastly, you've got this notion of data locking or data protection or data masking at the data level. How do I ensure that I've de-identified, locked, or redacted data that is the sort of crown jewels of the risk exposure and compliance challenge that our customers face today. I do think sometimes customers get confused between, do I need to think about this as an authorization and access problem, or do I need to think about this as a data locking problem? And I think that confusion stems from the fact that it's hard to think about doing both at the same time. But ultimately, for most of our advanced applications in credit card protection, in our largest healthcare deployments, customers end up doing both. They end up doing a pretty robust set of access control and perimeter defenses, and then they go ahead and lock the data at the data level as well. And there's a bit of blending you can achieve between those. You can get some degree of tiering, and that tiering can either be at the data sensitivity level. I'll give you an example. Some of those credit card brands have throwaway cards that are stored value, $10,000 customers with $10,000 lines of credit, and quite literally $1 million customers that have $1 million of line of credit on those cards. And so they've tiered their Hadoop clusters into 4 different levels of data sensitivity. They can afford to lose data, or they can afford to leak data, or they can afford to give more access to the bronze tier than they can afford to give to the platinum tier. And so that tiering of data can happen at the data level with the degree of sensitivity of data. And you can imagine that in the healthcare context equivalently. For certain pharmaceutical drugs, the sensitivity of loss is less than for other drugs where the privacy loss and sensitivity loss goes much higher. Flip that around, and you can also kind of model this by usage. That online payments provider I talked about, they've got 6,000 nodes of Hadoop. They've got 200 different users wanting to write analytics to it. Well, it turns out there's a tiering there. They've got users that are PhD data scientists that kind of need the keys to the kingdom to get super rich analytics done. And then they've got more casual use cases for accounting or other purposes, or website optimization that might want a more temporary access, or might need to be controlled in a more temporary way because they're a contractor there and they're not going to be, full-time, fully trusted, deeply trusted the same way that that PhD data scientist is. So we see tiering across both sensitivity of data as well as role and user coming to access that data. What we do is really 3 things to help our customers solve this security challenge specific to data protection. We run a discovery service that can go out and, based on your policy, identify where social security numbers, addresses, usernames, and other sensitive data elements lie. We then automate a protection service, which can either encrypt that data, mask that data, or redact that data. And we run reports and insights, dashboards and alerts and notifications to explain what we did. And I'm a security guy all the way back. And, in the beginning, in the 90s, when we were looking at internet security, there really wasn't any compliance. HIPAA didn't exist, PCI didn't exist, state privacy laws didn't exist, the European Privacy Directive didn't exist. The data non-residency laws around where you can move data from country to country, none of them existed. And so the challenge back then was really breaches and data loss. I think challenge number 1 today for all of our markets, including healthcare, is showing you did the right thing. It's compliance and audit. And so we spend a lot of time in the realm of reports because it's a place our customers struggle today. They struggle to know, where does the sensitive data lie, who is accessing sensitive data, and how is it changing and moving over time. I mean, one of the challenges in big data constructs is this data lineage and tracking problem. Data doesn't just go to a database and sit there anymore. It starts in the database, moves to a log collector, pushes into Flume, goes to HDFS, gets parsed and cleansed and repurposed in HDFS, sometimes outputted to a file system or Teradata or Exadata. Sometimes those cycles go around. And so you've got this challenge in both the protection of data, but particularly in the audit and compliance of data, that data is going to move on you, change, get edited, sometimes get deleted, sometimes get double encrypted, but you've got to show that you were doing the right thing the whole way. Just a quick blurb on who we are. We're 7 years old, venture fund startup. We got started in looking at in-place masking for databases. And what I mean by in-place is a couple of approaches to protecting data in a database. You can do it on load, like through an ETL process, or you can do it inside the data. And I mention this because some of the ideas that we built around locking data inside the data, running the application in the database, required us to think at a policy level and at a schema level in a different way. And that was very useful to us because obviously in the context of Hadoop, one of the fundamental properties is applications move to the data. And so now some of our security models, some of our paradigms, some of our user interfaces, some of the assumptions we made in how to run things from an in-database standpoint turned out to be particularly useful in the Hadoop construct. Because now we can run a MapReduce job that does all the things I just talked about. Implicitly, discovery, automated encryption, automated masking, and generate reports on everything end-to-end inside the data. You sit across a number of different verticals, all of which are really challenged by the compliance challenge today. We've been recognized by Gartner as an innovator and visionary for Hadoop data masking. And at the end of the day, fundamentally the things we can address are how much sensitive data is in Hadoop, where is it being loaded from, what directories and files have it, where is it changing over time. Once I know that, what am I doing to lock or protect that data? Do I want to use format preserving encryption and lock it in place? Do I want to use some more comprehensive encryption and lock whole sets of data at the row or file level? Do I want to mask data so that it's one-way protected, it's going to give me a unique value, but it's never going to give me back the medical identifier or the social security number from where it started? And last but not least, and we've seen this in healthcare already twice, is a good degree of data sharing across extended users. How can I safely share sensitive data with suppliers, partners, purchasers, QA, outsourcing, offshoring? This idea of data aggregation plus sensitive data protection gives customers the opportunity to think about sharing and using data sets, sometimes selling those data sets, but also leveraging those data sets for research and other purposes. We've already talked about this idea of sensitive data stratums, but we're going to see a lot of this in healthcare. We're going to see ranges of risk measured by stratifications of either data risk inside the data or access risk in the users trying to access that data. And so we want to really be blended. We think the right approach to solving data stratums is the combination of sophisticated roles mapped against blocking and masking techniques at the data level. Just a real quick walkthrough on how this works. Our tool starts with a definition stage. You go to our web user interface. You click on the sensitive elements that you want us to protect, social security number fields, credit card fields, address fields. In the HIPAA context, we have a HIPAA template for the 18 identifiers in HIPAA and some sophistication there and understanding some of those from an element level. But your job's kind of done there. Your goal is to tell us what you want to protect, and then we run in an automated fashion the rest of these. We're going to go out and detect that data in either structured loading elements through ingest tools like Flume, Scoop, FTP. We can also run natively inside HDFS, and we're going to run that discovery service and report back what we find. And you can set the tool up so that once you find something, you tell us what to do. We can redact it to asterisks, we can mask it in place, or we can encrypt it. And so we'll do that at the data element level, both in structured data and for unstructured data. Unstructured data is a little more sophisticated because we have to in place right inside that data stream, and we have to kind of watermark it so that we know that we've actually changed the social security number to a masked version. So we've got some pretty sophisticated watermarking technology to make that insertion in an unstructured data context. For structured data, we've got a couple different choices. You know, Hadoop doesn't have an implicit or intrinsic update function, so we can either take a column of data and create another column. We can take a file and create a masked protected version of the file and delete the original. And as of this month, we can take a column and take a data element and append it with a delimiter and create the masked value next to it. And it's that idea of creating both the original and the protected version that gives us some degree of doing that access tiering that I was talking about earlier. So, number one, define what you want us to go do. Number 2 and 3 are automated. And number 4 is report back. Tell us where you found it, where it sits, how it changes, and who accesses it over time. And we do that today primarily through a reporting dashboard, but we're also a pretty verbose technology in the sense that we record everything we do, every change made to our system, every change made to Hadoop that we know about. We actually have some API work going with Cloudera, also with Falcon from Hortonworks, so that we can get a more updated message stream of file changes important to that idea of data lineage that I talked about, keeping track of what changes happen over time. You know, a top-level summary of this is really these ideas that I've been talking about. You start with policy definition, you run a discovery service, we can discover data both in structured fields and unstructured fields, and then you think about what do you want to do with it. You leave it in place, redact it, mask it, encrypt it. Of course, for encryption, sometimes you need to get back to the original data, and so we have decryption agents that also run in MapReduce, and we have an increasing number of decryption services for different analytic tools. The most common example of which is Hive. People are running Hive queries against Hadoop, and they may need for certain applications the ability to derive back the original data. We have a decryption service in Hive that's tied to authorization to let users see back the original clear text data. In summary, we think an approach that is at the data level is very complementary to some of your other security architectures, but goes further in giving you robust compliance as well as visibility and protection against potentially insider threats and other threats to the sort of element level protection that you need to get done in Hadoop. And I've got a couple technical slides to look at if anyone has any questions in terms of technical architecture, how we run, how the tool works. But that was really the close of my prepared comments for today. I'll make sure these slides are made available if you guys want to get a copy of them. I'm free to hand them out. There's nothing in here that we can't share. So thanks for your time today, and I welcome any questions you guys might have. So the question was, do you only do protection in Hadoop, or how far does this tool extend to doing data discovery and or data protection in other information assets like SharePoint or Exchange or other places? You're about 80% right. The core focus of what we do today is Hadoop. But we got started in databases, so we do the same thing in Oracle, Microsoft SQL, MySQL, Postgres, and DB2. And that was really our heritage. We'll still sell those products, But candidly, there's a lot of larger vendors. IBM has tooling there, Informatica has tooling there. That problem has a big mature market behind it. We still have some large customer wins we're proud of there, but our main focus today, 80% of our engineering efforts, is really in tackling Hadoop. And we like Hadoop because the speed at which it moves means that a smaller, more nimble startup can sit here and say, Flume's who STP, FTP against Parquet, ORC. I mean, there's so much innovation in Hadoop that we can get there faster. But we do have tools for SharePoint that do discovery against files coming into SharePoint. I wouldn't want to tackle the Exchange mail system. There's some better tools if you're trying to solve mail compliance. Varonis is a good partner of ours. I would point you at some other tools for those are almost more like DLP, asset loss prevention tools. I think of us at the data element level, and in data element protection, it's really databases at Hadoop that take the primary focus of what we do today. It's a good question.
I have a quick question. So with respect to how your software fits into the architecture, is it basically you sit at the top of the data abstraction layer as a piece of center?
Yeah, so the question was, in terms of architecture, how should we think about this? Do you guys sit as a data interception layer? What are you doing? I kind of think of us as really two answers to that. A set of customers want to protect data before it ever hits Hadoop. One of our customers is Caesars. Caesars does a ton. Caesars is one of the largest innovators of data analytics in the world. For better or for worse, they want to get every penny out of you from every moment in your casino experience. They run 10 million OLAP analytic transactions a day. I mean, they're pounding the numbers very hard. They didn't want PCI Hadoop because PCI is $6 million a year of audit costs to them. So they said a credit card shall never go into Hadoop. And so to do that, we run all the ingests, the FTP loader, the NFS mount loader, the Flume loader, and we're sort of in situ running in those agents. I would say Interceptor is probably the right way to think about it. The way Flume and these other ingest methods work is they have an agent API that you can kind of, as you're passing data through, you can kind of, almost like in a round trip tap, you can send it out and back. And so for ingest methods, you should think about us as an interceptor. In the context of Hadoop, a large credit card company uses us really more as a continuous protection in MapReduce. So they'll solve loading into Hadoop on their own, but when it's in Hadoop, we are every 5 minutes across 350 nodes and 2 terabytes a day, it's over 10 petabytes now. We are every day, every 5 minutes running both to make sure we know where stuff is and to protect and mask any new stuff coming in. So I don't think of that as interception as much as I think of it as sort of a continuous operation model. And we're seeing more pressure to do that. Those large manufacturers of phones, they're feeding data. That's right. Post-process persistence as opposed to in-flight one-time scans.
Well, dealing with data streams, you basically have to get onto disk and show it.
That's right. It was the idea that we're onto disk and doing it continuously. We like the power of Hadoop. We're pretty bullish on some of our performance numbers. That large credit card company had a configuration challenge, and they ran us sort of, entirely against all the data. We have a configuration that says only work against the incremental, and they unchecked that, and so we ran against everything. And we were pretty impressed with our numbers. It's sort of leveraging the power of Hadoop, right? When you're running on 360 nodes, we masked 2.2 billion. We have a 2.2 billion row file, 8 of 50 columns. We masked in 22 minutes. And if you try to do that through FTP, if you were going to say, I'm going to load data to S3 and Amazon, and I'm going to load terabytes of data, it would take you a while, and it would take you a week to do that. Not just with our tool, it would take you a week to do that with anyone's tool. And so, to be able to do that in 20 minutes is really rewrite that performance architecture that Hadoop gives you.
What is the kind of IoT requirements you have for your systems?
So we get asked this question a lot because remember, as we get to sort of Hadoop 2.0, performance bottlenecks move. And the performance bottleneck in Hadoop is moving to an I/O measure. It used to be a volume measure, now it's an I/O measure. And so we're right in the thick of some sort of overhead or ways to measure that. The intellectually lazy answer is to tell you that we run at 2% overhead, but I'm not going to allow myself to say that because it really does vary by whether you're starting with structured or unstructured data, and it really varies by what type of element you're looking for. We pay a penalty to find names because we have to do a name lookup to be really accurate. Certain regex patterns are a beautiful thing. They're finely structured for us, and we can fly through them, like an ABA number or a telephone number. When it hits regex the right way, we're done. And so I don't want to give you the 2% answer because it can be 180% in certain places. We are either the full bottleneck, and you know it, or we are under the bottleneck, and that's how we'll operate. But anyone who doesn't give you an answer like that for Hadoop is lying. So, go ahead.
Especially small security or your solution. And the data, possible data. If I started to basically keep mapping the original data and the kind of possible that's a bit correct, right? So right?
Yeah.
So that needs to be correct, right?
Yes and no. Historically, yes. So I'm going to try to ask your question back to you a different way, which is, I have different sets of data, and I might want to protect the medical identifier, but I want to ensure that the medical identifier uniquely results to the same result in the protected form so that I can run joins and inference and referential integrity on the protected form. Historically, if you were using masking technology, the only way to do that, and we built this technology, so did a lot of other people, the only way to do that was to build a table mapping system. And you basically started with input data and the resultant data. Now you could hash the input data so that you're not at this complete exposure that you just steal that table and you're done. But even that has problems. LinkedIn did a hash password system for their single sign-on passwords, and they leaked 6 million out because of some other methods. But putting all that aside for a sec, the state of the art today is not to build a consistent mapping table. The state of the art today is to trick techniques like format preserving encryption, which is deterministic, and so you get a mask that is sort of like an encrypted value. We actually have some pretty nice innovation here. We actually take format preserving encryption and we intentionally break the S-chains in it so that you get format preserving hashing. And it's kind of cool from a crypto standpoint because it rides the coattails of AES, it rides the coattails of FPE, and it gives you a one-way mask you can never get back. And so I'm a security guy through and through. I mean, this is, in a slightly cute way, this is perfect forward secrecy. We can't get it back. We can't get it back algorithmically. So it is a unique, deterministic, cryptographically strong, one-way binded value to the original. I think that's pretty hot because now you get all of your inference and modeling and analytics tied to a number that only Sarah had. But if you steal this number, you don't have anything useful for selling or attacking or being exposed for Sarah.
But effectively what you've done is you've just created a key for that number, so you've really just obfuscated it.
You're absolutely correct, but if the goal is compliance and not having the original sensitive data, you've met that goal. But now we're going to go back to security 101. I mean, you can't You can't put it in a box and sand in the desert and throw it away. I mean, that would be the best way to deal with it, but then you'd have nothing. And in fact, if you took my Netflix example to the extreme and you said, any data linkage leads to inference, then that's asymptotic to zero, which means if you have to break every linkage in data, to your point, I'll answer your question the other way. If you have to break every linkage in data, you can get no value out of it. So I mean, your perfect security is asymptotic to zero, any ability to do anything with it.
But if you still have the full data set, you can sort of do a process, you basically encrypt it to then analyze it in memory and then toss that away, you know, and sort of build in memory mapping. We dealt with that. It seems secure either, but at least that way, by inspecting the data, you can do statistical analysis of data, and you can do a sense of what potential value, what's associated with what.
Yeah. I did get asked that question. I got asked that question by a large bank. They said, we've got data that we can, mask and protect, but when joined with other people's data, it becomes sensitive. And what are you guys going to do about that? I'm like, and I sort of thought, when joined with other data in your building, or when joined with, Texas HHS data about, drug results? And, I can't. It's sort of the unknown. It's the Rumsfeldian unknown unknown. I can't spell the unknown. But we can do some things. We can tell you that certain data has more entropy than others. I'll give you an example. If you tell me your date of birth and your zip code, we can play a parlor trick, and I will tell you your name. Because it turns out that those two elements combined have very low entropy. Not a lot of people in the world have your zip code and your date of birth. And so that's an example of the kinds of things that when I say, discovery includes risk scoring and aggregation, I mean, we're getting to a world in which we're going to start thinking about, I'm not just masking this element because I want to mask it, I'm masking this element because when joined with zip code, it's crushing. And our credit card companies tell us that, right? Your PAN number is useful. Your PAN number plus your zip code plus CVV is catastrophic, because that is the crown jewel of the purchase. It's not, hey, I have the credit card number from your card. It's that, hey, I have Track2 data, and I can look like your card in Estonia on someone else's card. So good stuff. I cheated and went over, but you guys took me there with questions, so happy to answer any more, but I'll set you guys free for lunch. Thanks.